Hi and welcome back to the channel. Today we're going to see the basics of high energy management in the aircraft. For this tutorial we're going to be using the Zibo 737-800 and we're going to assume that we know the basics of the descent modes that this plane has, such as level change, vertical speed, VNAV speed and VNAV path, and also other FMA terms such as altitude hold or VNAV altitude. We're going to be flying into Ezeiza International Airport in Buenos Aires, and I will try my best to get us on the ground safely. But before beginning this short tutorial, let's make clear what an aircraft energy condition is. Aircraft energy condition is defined as a function of the following primary flight parameters: airspeed and airspeed trend, altitude, vertical speed or flight path angle, drag, this is caused by speed brakes, slat, flaps and landing gear, and thrust. The crew should always maintain the appropriate energy condition for the flight phase, for example configuration, flight path, airspeed and thrust, or recover the aircraft from a low energy condition or high energy condition, which is what we're going to talk about in this tutorial. Controlling aircraft energy involves balancing airspeed, thrust and drag, and the flight path. In this tutorial we're going to get high on the descent profile, and this can be due to several reasons, but the most common ones are due to ATC restrictions. That means that the ATC sometimes does not clear you for descent, and this is usually due to traffic crossing below your flight path. Another reason can be a poor descent plan. Either way, the crew action should be the same. Try to recover the descent profile in a safety way, so the aircraft can be in a totally stabilized profile once at 1000 feet AGL. Alright, so right now we're cruising at flight level 370, and let's say that ATC does not clear us for descent yet. So let's take a look at the FMC. So what we will see is economic path descent. As we can see, we're 10 nautical miles away from our top of descent. We have our target speed, which says the planned speed for our descent, and below we have the speed restriction, which is usually 250 below flight level 100. However, we can change that however we want. The MCP, we have our flight level 370 set, so VNAV is not going to descend below that MCP altitude. It will respect that. So now we've got the famous reset MCP altitude message in the FMC, which basically is telling us that we are close to our top of descent point and our MCP altitude hasn't been changed, so we need to reduce it to a lower altitude. Let's clear the message and disregard it for now. And let's wait until we reach our top of descent. So the title of the descent page has changed to Active Economic Path Descent, and we have new features inside this page. For example, vertical deviation, which basically is telling us how high or how low we are from the VNAV descent path, and this can be seen in the FMC or in the navigation display. If the numbers in the navigation display appears below, we are too high. If they appear above, we are too low. To the right we have FPA, which means flight path angle. This, in simple words, means the trajectory that the airplane is flying. We are not talking about the pitch attitude of the aircraft, but we're talking about where the aircraft is going, not where it's pointing. So the FMC will calculate this flight path angle by itself. However, if we're flying an aircraft that does not have an FMC, we would need to calculate it by ourselves. So the formula is pretty simple, where the flight path angle equals the arctangent of our vertical speed divided by our ground speed. So let's make an example. Let's say that our ground speed right now is 300 knots and we're maintaining a vertical speed of 1500 feet per minute descent. So we know that 300 knots is the same as saying that we are advancing 300 nautical miles in 1 hour. So first we need to convert this to feet per minute. First we need to divide 300 by 60 to convert in nautical miles per minute. And then we have to multiply this value by 6076 because 1 nautical mile equals to 6076 feet. So the result of all of this will be 30,380 feet per minute, which is our ground speed converted into feet per minute. So now let's get back to the formula and replace the values. So our vertical speed is still the same and our ground speed is 30,380 feet per minute. So as you can see, now the result is 2.82 degrees, which is our flight path angle for our given ground speed and vertical speed. As you can see in this table, we can make sure that our calculations were right, verifying that for our given airspeed, which was 300 knots, and our given vertical speed, which was 1,500 feet per minute, so in this case we're going to use 1,486 feet per minute, we can see that our flight path angle for those given conditions is 2.8. This table is very useful for those who are not navigating using the FMC. To the right we have VB, which means vertical bearing, and this has to do with the waypoint we put in the line above, which in this case is our SOT at flight level 041. So if we want to reach our SOT at flight level 041, we need a vertical bearing of 3.3 in this case, which means basically a flight path angle of 3.3. To the right we have the vertical speed needed to reach our SOT, in this case at flight level 041. So a 2600 feet per minute descent should result in a vertical bearing of 3.3. The real airplane should have started to decelerate once we have passed our top of descent point. However, that's not modeled on the SIBO mode, well, at least not in this version. I'll talk more on that later. But let's reduce our speed. We can do that in several ways. One of those is pressing the speed intervention, so we are still on VNAV but controlling the speed. The other way is pressing altitude hold, so we can get out of VNAV and control the speed. But let's get back on VNAV for now. Press speed intervention and reduce the airspeed. Make sure you don't get below the amber bar, which is the minimum maneuvering speed. What we want to achieve by slowing down the plane is basically two things. The first one, we don't want to keep advancing more miles, so we don't get higher and higher over the profile. But the other thing is about energy management. So if we take a closer look into the FMC, we'll see that we are 5,000, almost 6,000 feet above the descent path, which is a lot. So we need to preserve some energy of the aircraft so we can use it later on. Let's say that we've been cleared to descend to flight level 200. So let's put it first on the MCP and let's descend. We can press altitude intervention so we can keep on VNAV and descending. So now is when we increase the speed and we use this energy that we have been keeping, so now we can increase our airspeed. We can do this on level change as well. Let's keep on level change for now and make sure you don't get over the VMO, which is the red bar. So in the FMC it says that our flight path angle is increasing rapidly, which is good. We want to get down as soon as possible. If we take a closer look into the PFD, we can see that as our indicated airspeed increases, the aircraft will pitch down, so this will cause our vertical speed to increase as well. We could even use a speed brake to increase even more our rate of descent, but for now we're not gonna use it since we are far away from the airport. As we can see, we are reaching our target speed of 300 indicated. So as we reach our target speed, our vertical speed will start to decrease, so our flight path angle will decrease as well. This is because we are not gaining energy anymore, but we're just maintaining our descent path, which is not a lot in this case. We're still 3,000 feet higher, and our flight path angle is 3.7. So we need to increase it even more. This can be done in several ways. One of those is increasing indicated airspeed or extending the speed brake. In this case, we'll increase our airspeed to 320, and let's gain some energy back so we can descend faster. So we still have a long way to go. I will come back with you when we are closer to the descent path. Alright, we're back. We've been cleared to descend to flight level 100, and as you can see, we're getting back into profile. We're just 100 feet above the VNAV path. However, now we want to get below the descent path. Why? Because since we have increased our airspeed to 320 right now, and our target speed was 287, we need to bleed off this excessive airspeed. So how can we do that? We need to get below our desired path. So the rule of thumb is for every 10 knots of excessive airspeed, we need to be at least 200 feet below the desired path. So in this case, we have around 30 knots of excessive airspeed, so let's descend 600 feet below the path. So as we get closer to our desired altitude, which is 600 feet below the path, we can engage VNAV again. So let's press the VNAV button and see what VNAV is going to do. Basically, VNAV is realizing that it's below the path. So what it's gonna do is going to try to level off until it captures the path. But while not actually level off, it will maintain a 1000 feet per minute descent. So that 1000 feet per minute descent will keep a constant descent and will give us the decrease in airspeed that we want. So as you can see, the speed is getting back to 287, which is our target speed, and we are getting back into the profile. So this rule of thumb works pretty okay in no wind conditions. So we're back into profile, and we are descending now on VNAV path. Now let's make another scenario. Let's say that we've been clear only to flight level 100. So let's keep descending until we reach that altitude and see what happens.
$1,000 to go.
Now as you can see, our target speed has changed to 250 since that was our speed restriction. So VNAV will automatically start to decelerate to 250, pitching up a little bit. Now keep in mind that VNAV will always respect the altitude that is set on the MCP. So in this case it's set to flight level 100, so VNAV will not descend below that altitude. So as you can see, we've now entered to VNAV altitude, which is basically the same as altitude hold. That means that the aircraft will level off at flight level 100 in this case. So in this scenario, let's say that ATC does not clear us for descent. So the first thing is reduce the speed. We can do this by either going into speed intervention or going into altitude hold and get out of VNAV. So now we're out of VNAV, we're into altitude hold, and we're decreasing our speed to flap up speed. So we will keep maintaining this altitude and flap up speed until ATC clears us for descent. However, as we get closer to the airport, the situation gets worse because we don't have much time to recover, right? So if you are too high, you can request delayed vectors for the runway, or you can just ask for a hold until you bleed off speed and altitude. Now let's say that ATC finally clears us for the approach. So the first thing that we need to do is to descend. So let's press level change and increase the speed. Now we are below 10,000 feet, so our speed restriction is 250. So let's increase the speed to 250 and let's get back into profile. Now, as we can't increase even more the speed and we are getting closer to the airport, now is a good time to use the speed brake. The speed brake will help us to increase our rate of descent so we can get onto profile faster. Now, as you can see, we're getting closer to the localizer. We're 5 miles out. Ideally, we should be right now at least flaps 5 to intercept the localizer. However, right now it's not possible. We're still fast and high. We want to keep descending, but we don't want to overshoot the localizer with our high airspeed. So what we can do right now is use vertical speed. That will allow us to keep descending while losing airspeed. And let's reduce our airspeed to flap up speed. So let's put around 400 feet per minute descent. Let's earn furlock. Okay, furlock is captured and we are decelerating while still descending. It's not the most optimal way, but it's what we need right now. So now we are reaching flap up speed. We can go back to level change so the aircraft descends with pitch. We're gonna keep the speed brakes extended for now. And let's arm approach. Okay, glide slope is armed. Now we're getting closer to the final approach fix, so it's a good time to start extending the flaps. Let's go for flaps 1 and command the speed for flaps 1. Now we don't want the aircraft to level off, so let's go to vertical speed so we keep descending while losing airspeed. Okay, let's go for flaps 5 speed.
1,000 to go.
Now, I'm using speed brake with flaps, which is not recommended, but in this case it's necessary. However, we have a limitation that says that we can't use speed brake with flaps 15, so let's lower the speed brakes as we get closer to the final approach fix. You can adjust your vertical speed observing the altitude range arc in the navigation display. That will give you an idea where you are going to reach your MCP altitude with that specific vertical speed. So when that below glide slope, let's go gear down, flaps 15, arm speed brake.
$2,500.
Okay, glides up captured. Let's set our missed approach altitude and let's go for flaps 30. And let's go for the approach, which is 143. So ideally, you want to reach your final approach fix with power on idle until you put your final flap position. So we've basically done that right now. We've used all the tools available in the aircraft, such as a speed brake, such as energy management, and in the end we've used the flaps and gear. However, keep in mind that flaps are not meant to be used for drag. Okay, now let's focus on the landing. Okay, let's go manual flight. As you can see, we have a little bit of right crosswind and a little bit of tailwind, but not a big problem right now. So right now we're approximately with a 6 degree of a crab angle to the right. So when we flare the aircraft, we want to push the left rudder in this case to align the aircraft with the runway so we don't touch down with a crab. When we apply the left rudder, the aircraft will want to roll to the left. So make sure you apply cross controls. So we're going to bank to the right a little bit in this case.
$500. $400. $300. Minimums. $200. $100. $50. 20.
Okay, 20 flare,
10.
10. Now let's push the left rudder, keep the airplane straight, touchdown.